VITA 100 is the standard going forward for military avionic applications. It's in its infancy at this point, but it's got a lot of new and interesting things. In particular, one of the aspects is the form factors. Dan, could you talk a little bit about the new 4U form factor that's part of VITA 100?
Sure. So, just to step back a little bit, VITA 100 is focused on providing continuing support for 6U and 3U, but the working group had noted the need for something in between the two, which ultimately has become 4U. And really, what that's coming out of is it's coming out of two things. One is the technology that we place on boards today is becoming physically bigger in size, and it requires the need to have some more module real estate to actually place that on the module. And then secondarily, with the I'll say the maturization or the growing up of MOSA in general throughout industry, you're starting to see payloads that look different than what the payloads looked like before. And 4U starts to satisfy some of those new emerging MOSA aligned payloads.
Does the larger chips that we're seeing for, AI accelerators and GPUs come into play with that?
100%. I mean, as people go and look at system on package and on the ability to consolidate more functionality at the component level to deal with emerging issues with interface interconnects between components and including things like signal integrity across multiple jumps, that consolidation requires that the interfaces and the components themselves grow. And in some cases, they outgrow what their form factor looks like today. I mean, just at Mercury alone, we used to look at things that were high density computing where you would see 4 compute nodes on a module. That soon went to 2 server class components on a module. And now today, right, there's only the ability to put down 1 server class component on a module due to power, IO, or physical constraints.
Well, speaking of physical constraints, what about the connectors, Mike?
There was a study group that laid out all the requirements for connectors, and from the physical, mechanical, environmental requirements. One of the biggest challenges was getting the higher density, getting almost double the pin count that we get from current OpenVPX today. And then obviously the challenge of getting to higher speeds, doing 100 gig lanes. And that required you're bringing all the pins together, you're increasing the density within the connector, you're working around the existing package size as OpenVPX. So noise becomes an issue. You've got to design around that. We've introduced shielding into the backplane connector. We've got strip line wafers. It's still a wafer-based connector, similar to what VITA 46 is today, except it's a strip line wafer with very high-speed laminate and ground vias. A lot of engineering work's gone into the development and design of this connector. And we've designed it so it's modular, so it fits into kind of the same architecture we have today, where you can build a slot or a module and add connectors on a card. You can save space for apertures where you can introduce coax or optics. And it meets a lot of the existing requirements. One of the other things that we've added as the development occurred is we've got a connector that almost doubles the pin count, still fits in a 1-inch slot pitch, but we're also introducing a 6-pair connector where we have 6 differential pairs per wafer, which supports a 1.2-inch slot pitch. So there was a need for higher pin count in certain applications like high density switches that drove an alternate connector that requires a larger pitch. But a lot of development work's gone around it.
Well, higher performance often means hotter systems. Mark, could you talk a little bit about cooling and standards, because that's definitely part of this mix?
Sure, you're absolutely right. So in OpenVPX, over time, various cooling mechanisms have evolved. Starting with air cooled, we add that and added conduction cooling, then liquid flow through cooling, and various air flow through cooling methodologies. Again, learning from our past, we're adopting from the beginning all of those basic approaches to cooling the computing hardware. But we're also, again, learning from the past, correcting some of the mistakes we made or were forced to make in the past. For instance, it's very difficult to mix, or it's tricky, I would say, to mix a board design that's intended for conduction cooling and then adapt it for liquid cooling. And so we're taking some steps to try to make that a little bit easier, so you can have a single board design that can be used, say, in conduction cooled environments or liquid flow through environments, or even air flow through environments. And there's also some variability. There's 3 different air flow through standards. I think it's 3 or 4.
Yeah,
In any event, there's a lot in OpenVPX, and we really want to collapse that down to a single approach, just to make the market a little more stable, a little more focused, and improve interoperability, all with kind of with MOSA in mind.
Keeping things cool is a lot of fun, but given that we have higher performance systems, oftentimes we need to give it a lot more power. Mike, could you talk a bit about the connectors with respect to power? Because I think there were some changes there in terms of being able to provide more power to each of the boards.
Yeah, so one of the features of the VITA 100 connector is that for power, today in OpenVPX, we have power blades. They are an FR4 based PCB with copper layers on it. We're in VITA 100, we're using a copper alloy contact. So it's going to be solid copper alloy. So we'll at least double the current rating for what we have today in OpenVPX. So as we go through these modules and looked at the different form factors and the voltage levels, we can support power through a typical card with a single power contact, and then we assign one for return current. And we're leveraging that same technology into the power supply connectors. So the power supply connectors are also being developed, and we're working on proposals around that, but we can leverage that same technology into the power supplies themselves.
Well, we've been talking a lot about the physical aspects of these standards, but there's a lot of software that's involved with this, including part of the standards. Dan, could you talk about the system management, for example, where it's tied together?
Yeah, system management in VITA 100.20 is looking also to revolutionize how we can manage the individual elements of a VITA 100 system. When we, first built out 46.11, that was basically built to be an interoperable mechanism to allow you to get hardware level management information and some limited configuration into your hardware system. It also happened to be the first standard since VME, which not only just defined mechanical and electrical signaling, it actually defined software protocols and APIs to communicate between VITA elements. With 100.20, we're going to raise the bar on that and attempt to try to bring net-centric system management to the VITA 100 system, which would align it with the kind of commercial systems you see today for distributed processing, both in cloud-based systems or hybrid-based systems that you use every day today.
Well, as we've been having this discussion, everybody's been dropping specific version or standards along the way. To wrap up, Mark, what's your favorite at this point?
Well, I mean, virtually all my time in VITA 100 land is on the base standard .0 because that's going to be the basis for everything. And they're working on a very accelerated schedule. They're looking to have that wrapped up before the end of the year, the end of 2025. And so there's a lot of work to be done to attack that. So I can't say that it's absolutely my favorite, but it's the one I'm certainly spending the most time on.
Okay. Mike, how about you? Do you have anyone that you want to highlight?
So I'm involved in a number of them because the connector technology, carries over into other standards, but I chair 100.30, which is the VPX connector standard. So we're working on an open standard around that. Yeah, I'm not sure it's my favorite, but I'm the most passionate about it. And then 100.31 is coax and optics, which we're really pulling in the best from OpenVPX into that. But a lot of the same technology we're leveraging there. But so those two.
Great, Dan, you get to wrap it up.
Yeah, so kind of like Mike, right? Since I chair 100.20, I have to pick that as my natural favorite. But seriously, system management has been something throughout my career that I've been focused on, and so it is a passion of mine to allow us to bring together systems that we can configure, operate, diagnose, and enable right quickly. And I think that with that passion, I think has exuded beyond other members, of the VITA community. And I think we're going to make some really good, important changes into that